Assalamu alaikum, my dear students. I hope all of you are fine and having good health. And our today's topic, we will discuss about the allotropes of the carbon. So let's have a look at what are the allotropes of the carbon. Basically, you must know that what are the allotropes. Allotropes are basically when we have an element and this element can exist in more than one crystalline state. Then these crystalline states are mainly known as the allotropes, and this process is known as allotropy. And here we will discuss about the allotropes of carbon here. Allotropes of carbon are basically three. The number one, we have diamond. The second allotropic form of carbon, we have graphite. And the third allotropic form of the carbon we have is buckyball. So let's discuss that one by one. Here you can see that the allotropic forms of carbon, this is the structure of diamond, this is the structure of graphite, and this is the structure of fullerenes. You can say that it is, in simple words, buckyball as a hollow sphere structure. So let's start the first one allotropic form, which is diamond. So the diamond, basically it is the crystalline allotropic form of carbon. It is the allotrope of carbon element. Its symbol of carbon is capital C. And the carbon exists in the cubic form. Basically, here the carbon exists in the cubic form, and each carbon is tetrahedrally bonded. Tetrahedrally mean one carbon is having four bonds with the other carbon. And this picture you can see that if we have this carbon, it is bonded to four other carbons, 1, 2, 3, and 4. Again, if we have a look on this carbon, or it is bonded to other four carbon atoms, so they are tetrahedrally bonded. Next we have the covalent bond that exists between diamond. Covalent bond that is going to be exist between diamond, it is very strong bond, so that's why diamond is very hard. So there are question arises that why diamond is very hard, because the covalent bond that exists between the carbon atoms in diamond, it is very strong bond, and the melting point of diamond is also very high. So on the other hand, diamond, it is a bad conductor for electricity. Why it is a bad conductor for electricity? Because all the carbon atoms are bonded. There is no free electrons that may be used for the conduction purpose, and they are tightly held to each other. So these are the properties of the diamond. Next we have the second allotropic form of the carbon, which is mainly the graphite. So why graphite? It is the form of carbon, and what is the structure? In graphite, each carbon atom is covalently bonded. It is also covalently bonded to other three carbon atoms, as well as it is having three bonds of other carbon. Likewise, here we have, this is a central carbon. It is having bond with the three other carbon atoms, 1, 2, and 3. Likewise, it is also having the three bonds, 1, 2, and 3. This is also having three bonds. So it is covalently bonded to three other carbon atoms rather than four that was in the diamond. And here the carbon exists in the hexagonal form, As the carbon exists in the hexagonal form and it is gonna to be form the sheets or in the form of layers. Here you can see that this is the first layer and this is the second layer. So it exists in the form of layers. When the carbon is going to be exist in the form of layers, then these sheets are linked with the carbon atoms and the forces are very weak in between them. As these forces are very weak, so these sheets or the layers can slide over each other. These layers can slide over each other. So that's why graphite, it is very soft. It can be used as a lubricant in in the heavy machinery. On the other hand, it is also a good conductor of electricity because it has free electrons. Why it has free electrons? Because only carbon is having three bonds with the other carbon and the one side is free. So this is about the graphite. Next we have the buckyball. This is the third form of carbon. Buckyball basically it is the crystalline allotropic form of carbon. It has been recently discovered in almost 1985 and the buckyball mainly consists of 20 to 100 carbon atoms and when we talk about the buckyballs, the atoms are arranged in the form of hollow cage. They are arranged in the form of hollow cage, or we can say that a ball-like structure like the football. So the carbon atoms are gonna to be linked with each other and they adopt the shape of a football like a hollow sphere. And in this picture you can see that it is like a hollow sphere and the carbon atoms are going to form a cage like structure. And in the buckyball all the carbon atoms are bonded together and as they are bonded together and they are making a pentagonal or hexagonal, they are forming a pentagonal or a hexagonal structure. On the other hand, the buckyball, it may be used as a semiconductor. Now, what are the semiconductors that have both the properties of conductors and non-conductors are known as semiconductors and buckyball can be used as semiconductor or it may be used as a superconductor. Superconductors that can conduct electricity very easily and on the other hand it can be also used as the lubricant. So all this about is carbon and its allotropic form. I hope you guys understand and if you have any queries you may ask me about that in the comment section. And the next topic we have it is about introduction to the solutions. So we will study about the solutions in detail in the next video. For that time have a good day and Allah Hafiz.